We now talk about magnetism of the Earth. The exact cause of magnetism of the Earth is not known, but the magnetic field of the Earth acts as if there is a giant bar magnet inside the Earth. There is no giant bar magnet inside the Earth, that is for sure, but the magnetic field acts as if there is a giant bar magnet. Also interestingly, the magnetic pole and the geographic pole of the Earth do not coincide. In fact, they are apart by 11 degrees at the poles. So that means that this angle between the north magnetic pole and the geographic north pole is 11 degrees. Now we talk about the declination. Now the angle of declination measures the angle between the planes which pass through the geographic north pole and the magnetic pole. So we have two planes. One plane is passing through the magnetic pole and the other plane is passing through the geographic pole. So this is the plane which is passing through the magnetic pole. And the other plane, this plane, the plane behind, this plane is passing through the geographic north pole. So the angle between these two planes, so this angle between these two planes, this angle is called angle of declination. So at any point in time, you have a proper magnetic compass. The magnetic compass will give you the north magnetic pole. So to find the exact geographic north pole, you need to know the angle of declination at that particular point on the Earth. So say if you're here on the Earth, the needle will point towards the north magnetic pole, but geographic north pole is somewhere away. So you need to know the angle of declination to find out the exact location of the geographic north pole. The second thing we need to know about is dip or inclination. Now notice the magnet, this is completely horizontal at the equator and it is completely vertical at the poles. So you see this magnet is completely vertical here at the poles. This is completely vertical here at the poles and it is completely horizontal here. So it is horizontal here and it is vertical right here. So in general at other places, for example here, here or somewhere here, this magnet will make an angle theta with the horizontal. So if this is called B, the magnetic field of the Earth, so you have B cos theta here and B sin theta here. So from here you can actually measure the angle theta you can measure, and this angle theta is called the dip or the inclination. So the angle theta the compass will make with the horizontal is called the angle of dip. So you notice all these angles of dip right here. The compass is dipping, 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 and here it is perfectly, theta is just 90 degrees exactly at the magnetic pole, theta is 90, and here theta is 0 at the equator of the equator corresponding to the magnetic pole. Finally, notice the poles of the giant bar magnet inside the Earth. The south actually acts as the north geographic pole and the north of the magnet acts as the south geographic pole. You need to keep this distinction in mind.